Application of electric double layer. Concentration and charge effect valence on the diffuse layer. As you can see in this, from the picture below, both increase salt concentration or an increase in ion valence will compress the diffuse layer. This will allow particles to come closer approximately to each other and thus promote flocculation of the soil particle. So if you have a salt, the electrical high salt, look here, if you have high salt, the electric double layer compacted, and consequently if you have two particles, the particle approach to each other and coagulate. While if you have a low concentration of salt, these let the particle to be away from each other and dispersion will be conducted. The same here, if you have a high valent, divalent and monovalent, if you have divalent, the electric double layer compacted and consequently flocculation will be carried out. However, if you have a monovalent like sodium, so the dispersion is conducted. For this reason, if you have a sodic soil, means that have a monovalent of sodium. Sodium is a monovalent, so the presence of sodium disperse particle and cause problem of aeration and drainage problem. But to solve the problem of sodic soil, you add a calcium source, because the calcium is a divalent and can coagulate the particle to each other. The thickness of double layer decrease according to the valence of cations in the following order. Monovalent ion is a higher thickness than divalent ions and trivalent ion. Look here. The thickness of electric double layer decrease by increasing the concentration of electrolyte. If you have a diluted electrolyte, you will have a more thick double layer than a higher concentration of electrolyte. Effect of ion radius on thickness of double layer. The thickness of double layer decrease by decreasing the ionic radius. There is a thickness decrease, and if you have a lower ion radius, then you will have a lower thickness of double layer, like here. A sodium here more than potassium, nor more than lithium. The thickness of double layer decrease by decreasing the ionic radius. Okay. Effect of electric double layer on clay suspension stability. The thickness of the electric double layer is between 300 to 400 angstrom. When the thickness of double layer is more than 400 angstrom, repulsion occurs between clay particles. When close to each other due to repulsion between. So repulsion is conducted when close to each other due to repulsion between similar charge. You know that the particle have a negative charge, and the cation is surrounded by cation with a positive charge. So when particles approach to each other, they are the repulsive force is conducted, and subsequently dispersion and stability of suspension are occurred. So repulsive force is dominant when the thickness of double layer between 300 to 400 angstrom. But so if you have this thick double layer is found when you have a diluted soil solution, or when you have a monovalent ion. Okay. Attraction force are created between the soil and called van der Waals force when the distance between the particles reaches 200 angstrom. Angstrom equal 1 to the power minus 10 meter. So it's a unit of length here, angstrom. So if you have a high concentration, a compaction of electric double layer will be carried out, and it may reach less than 20 angstrom or less. Consequently, the result of this is that the flocculation of clay granule is occur. A distance between the particles greater than 20 angstrom, the repulsion force reveal and lead to the stability of clay suspension, dispersion. The low concentration of electrolyte, the clay particles are trapped in a relatively thick double layer, which reduce the probability of suspension to be fluctuated. With a high concentration of electrolyte, the double layer will be compressed and change of covalence, the change between the particles increase, and eventually the dispersion of the aggregate particle, the deposition of the aggregate particle is conducted. So if you have this means that if you have a suspension of the soil on a cylinder, if you have a cylinder and put a soil, for example, uh, 10 gram of the soil on 1 liter of the 10 gram or 50 gram of the clay soil on a 1 liter cylinder, and put 1 liter of water, shake, and then you will observe that the clay particles are suspended on the cylinder. If you put some salt, then the electric double layer will be compacted, and consequently the distance between particles will be less than 20 angstrom, and the aggregate and fluctuation will be conducted. So here summarizing what we said: effect of cation valence and electrolyte concentration on stability of clay suspension. Valence: if you have high valence, then you have the thickness of double layer decrease, attraction force will be conducted, suspension of stability will decrease, and vice versa on low concentration, repulsion and stability increase. Here, high concentrations the same as a high valence, the same attraction, while low concentration like a low valence, repulsion. Effect of fluctuation and dispersion on plant growth. Plant root need aeration, okay? And compacted soil or dispersed soil particle affect negatively on growth, on root movement and uptake. Okay, so dispersion is not favorable. You usually need fluctuation of the soil particle on clay soil. Plant root growth naturally required stable and porous condition with adequate aeration. Soil stability occurs in clay containing soil that can be combined with the factor that help stabilize this stability. If clay particles are dispersed, the soil became compacted and becomes sticky when it's wet and become hard when it is dry. Okay, and it's not favorable for the soil. For this reason, it is recommended to add calcium and magnesium to acid soil to serve as soil fluctuation and prevent the toxic effect of aluminum. Also, we should add a calcium source for sodic soil, which have a sodium is dominant on double layer. So you have to exchange sodium. A sodium causes dispersion. You have to and because it monovalent. You have add a divalent cation like calcium to make aggregation and circulation and increase aeration and increase favorable properties of the soil. We will complete the absorption phenomena in next lecture. Thank you.